Okay, we are looking at 2.3 class pre-notes. The objectives in this video are to learn how to use the zero factor theorem to solve a factorable quadratic equation. Notice it has to be able to factor to be able to use this property. And learn how to use the square root method to solve special quadratic equations. The thing to note about a quadratic equation is that it has x squared as the highest power in the equation. And generally we want to write it in this format where we have it equal to 0. There will be 4 ways to solve these. We'll do 2 of them on the pre-video and 2 of them in class, the harder 2 obviously for class time. One is if you can factor it, you should factor it, and then the zero factor theorem, which is below, says if p times q equals 0, then either p had to equal 0 or q had to equal 0. So that's what we mean by the zero factor theorem. The square root method is only going to be applicable in special scenarios. And then complete the square and quadratic formula will both be covered in detail in class. So, and then sometimes this is just a side note. If an answer appears twice or a factor appears twice, that is called a multiplicity. If it appeared 3 times, it would be a multiplicity of 3. A double root is what we call it when it's a multiplicity of 2. So let's look at these 3 factoring problems that I have in the first example. First thing I always check for is a GCF. So does 4 go into all 3 of those numbers evenly would be the first thing to check since they all look even. If 4 doesn't go, I know 2 does. 72 divided by 4 is 18, and 324 divided by 4 is 81. So yes, this 4 can be pulled out front as a GCF. So that would be my first step, since everything was already on one side. And then for a trinomial, 1 times 81 is 81. Factors of 81 are 1 and 81. 3 goes into it, I believe. 2 does not. Yeah, 3 and 27. 4 does not go into it evenly. Neither does 5, 6, 7, 8, but 9 times 9 goes into it. And it makes a positive 81 when we multiply, but a negative 18 when we add. So it's going to be 2 negative 9s. So I'm going to do my scratch work over here. That negative 18x in the middle will become 2 negative 9x's. Factor by grouping. This is x times x minus 9. Pull out a negative 9 in the second pair, and that would leave me with x minus 9. So we get x minus 9 twice, once for the match and once for the leftovers out front. So this would be 4x minus 9 times x minus 9 equals 0. You set each part equal to 0 because of the zero factor theorem that we were just talking about. So 4 equals 0 doesn't make sense, but if I add 9 over, I'll get the same solution here. I see that 9 is a possible solution to this equation. Okay, for part B, you can't really work this out yet because it's not equal to 0. To be able to use the factor theorem, it has to be 0 on the other side. So we have to redistribute this. This would be 8x squared plus 30x. I'm going to subtract the 27 over so that I'll have it equal to 0. We need to figure out 8 times negative 27. That would be negative 216. So over here, negative 216. Factors are 1 and 216. Oh, I wrote it backwards. $216 is obviously divisible by 2. It goes in 108 times. Is it divisible by 3 is the next question. Yep, 3 and 72. Is it divisible by 4? Four and 54. Is it divisible by 5? No, because it doesn't end in a 5 or a 0. I believe it is divisible by 6. Oh, that's times. Clear that out. Divided by 6. 6 and 36. And I can stop here even though I haven't got my full list, because for me to multiply to a negative and then I have to have opposite signs, and this was 36, by the way. If you're going to add to 30, if you had negative 6 and positive 36, that would do it. So we're going to take this and turn it into 4 terms. I'll put the 36 first, then the minus 6x minus 27 equals 0. We can pull a 4 and an x out of the first pair. That would be a 2x plus a 9. We can pull a negative 3 out of the second pair, and that would still be 2x plus 9. I have a 2x plus 9 in the first parentheses and a 4x minus 3 in the second. And I'm not done because I'm trying to solve this. So my next step is to set each of those equal to 0. So 2x plus 9 equals 0, or 4x minus 3 equals 0. Subtract 9, and divide by 2. So one possibility is negative 9/2. Add 3, and divide by 4. And the other possibility is 3/4. So x could have either been negative 9/2 or 3/4. Okay, for C, we have to clear the fractions first because this one has a rational in it. If it was me, I'd factor that into x plus 2, x minus 2 to make sure you have the right LCD. So my LCD is x plus 2, x minus 2. If we solve each of those to figure out what they would be, if we set them equal to 0, you see that you can't plug in negative 2 or 2 because those would cause 0 denominators. So we multiply everything by x plus 2, x minus 2, and we've learned that certain things cancel out. So in the first parentheses, an x minus 2 would cancel, and you'd just be left with 3x and x plus 2. In the second fraction, you'd have your 1 on top. The x plus 2's would cancel, so you'd be left with x minus 2. And then don't lose this negative here. The other side would just be negative 4, because if you multiplied by this, the bottom would completely cancel. So this is 3x squared plus 6x plus x minus 2 equals negative 4. Combine some like terms, and then move this negative 4 over by adding it, so that would make that positive 2. And now we again have to do the factor by grouping. 3 times 2 is 6. Factors of 6, though, are very small, just 1 and 6 and 2 and 3. And for it to be a positive 6 and then add to 7, it would have to be both positive. So 3x squared plus 6x plus 1x plus 2 equals 0. Pull out a 3 and an x out of the first pair. Pull out a positive 1 because they have nothing in common, but you still have to pull something out for the second pair. And we get x plus 2 equals 0. Sorry, I didn't write the 3x plus 1. So we solve this. This would be 3x plus 1 equals 0, or x plus 2 equals 0. That would be negative 1/3 because you would subtract 1 and then divide by 3. And this one would be negative 2, which is not a solution because that is one of my domain restrictions. So this is why this is crucial, because you get 2 answers and only one of them ended up working. It could either be they both don't work, one works, one doesn't, or they both work fine. So you have to have that check about the domain. Okay, solving by the square root method. This is a special case. Here's how what we're really looking at here for these. If you see something squared on the left side and isolated, so something squared equals a number. Now for us, because we don't know about imaginary numbers, right now we want this number to be positive. Later on when we learn about imaginary numbers, it won't matter what it is. So they say isolate the part that is raised to the second power on the left side. So we're going to get the part that's squared all by itself. Then the way we do this is we do the opposite of squaring. You take the square root. The kicker is, because you're doing the opposite, we don't know if the original was positive or negative, because negative 2 squared is 4 and positive 2 squared is 4. So that's why we throw in the plus or minus, and then we solve for x. And then finally, just make sure your radical is simplified. Here's just some more notes on the square root method. So for example, look at my first one here. This is something squared equals 31, a number. So if I wanted to take the square root of both sides to get rid of that squared part, that's legal as long as I remember to put a plus or minus on the other side. So the square and the square root cancel out, and that would just, and we assume all of our variables are positive when we solve these. We're not doing absolute value stuff. And then this would be plus or minus the square root of 31. Finally, we need to solve for x. The typical way we do this is we put the negative 4, because that's what it would be if it moves over, in front of the plus or minus. 31 is a prime number, so there's no perfect squares that go into it. On my math lab, they may have you break this up into 2 separate answers, which just means you write it once with a minus sign between them and once with a plus. I'm okay with this on the test. For B part, we need to isolate the part that's being squared first, otherwise we can't take our square root. So this would be, get that 9 out of the way. That's 7/9. Then we would take a square root of both sides, not forgetting our plus or minus over here on the right. This would be x minus 1 equals, and I'm going to split this into 2 radicals. Square root of 7 is just square root of 7, but square root of 9 is 3. And then my final stage would be to add the 1 over. So x equals 1 plus or minus square root of 7 over 3. All right, that is the end of the pre-class notes for section 2.3.